Hello, good morning, good afternoon. My name is Marcelo Rovai. I am a professor at Federal University of Itajubá in Brazil. I'm here today to talk with you about leveraging any microcontrollers and data collection at Edge Impulse Studio. So far, you got a lot of knowledge about Edge ML, Edge AI, TinyML, what is that, and what is Edge Impulse Studio, how we connect a microcontroller to the studio. But even in spite of the fact that you saw one example of a microcontroller so far, it's most common example, the Arduino Nano BLE33, there is a lot of other hardware that can be connected to the Edge Impulse Studio to capture data and also to take your training model to be deployed. Okay, and that was we'll talk today. Microcontrollers and data. In fact, the most important part of any data science or machine learning project is data. So we'll talk a lot about the different type of the data and how we handle that data with the Impulse. Okay, perfect. So let's start quickly about hardware. Okay, we have a lot of the first thing that my students used to ask me is, oh, what's the best microcontroller or to use with the Edge Impulse or to use in a machine learning project? Of course, the answer is it depends of what you want. There is a lot of in the market. The first thing that came to our minds are developing boards. This is the first thing that you should understand. For example, here we have a selection of several 32 bits developing boards that you can use in typical machine learning projects or TinyML projects. So you have, for example, this is a microcontroller. The microcontroller, this is square, this black square here is a microcontroller unit, or MCU. A microcontroller is a CPU plus memory, could be RAM, that is the memory that you're using during the let's say when your program is running, and flash or ROM, that read-only memory where you code or your program is storage. So when you disconnect it, you lose everything inside the RAM memory, but the data that are inside the ROM is kept. Perfect. So if you talk about the CPU that's inside here, for example, the Raspberry Pico, it has a dual core M0, Cortex M0. Okay, it's a 32-bit CPU, powerful, and that you can use for several types of projects. But because those are developing boards, they have more than the microprocessor unit. You'll find in those kind of boards, for example, it's more common in almost all of them. You have a kind of interface to connect with your computer. You have some kind of a power regulation to receive 5 volts, for example, and convert to 3.3 volts. That's most common in such kind of line of PCBs, and so on. For example, we can have different sensors in the PCB. For example, the most common is the Arduino Nano Sense. You can find the microphone. You can find IMU is an inertial mobile unity. Okay, it's the accelerometer, gyroscope, magnetometer inside the PCB, color sensor, etc. Okay. You can have camera, for example. It's the case of the new Xiao Sense, okay, the SP32S3, or you can go to the most, let's say, the high end of the TinyML devices that are the Pro line or the Arduino Pro line. It's the Portenta and the Nikla. It's important for you guys to know that when you talk about developing boards, what we're talking about here are boards that you use during developing time. Because when you go for a product, okay, when your model is okay, you are okay with that, usually you find, for example, let's say that you use this PCB for the project. In general, you develop your board with the microcontroller plus, for example, the sensor that you need, a microphone or accelerometer, and that's it. Because what you want is the low memory possible, or the low power possible. Sorry, no memory, the low power possible. Correct? I mean, so you don't want sensors that you will not use, etc. So that's the first thing that you should have in your mind for your project. How much memory I need for my project, for example, what kind of sensor I will need for my project, and so on. If you go here, for example, I left for you guys here. If you click here, you see, for example, this is very interesting. It's a magazine that appears as a few months. There is a lot of microcontrollers here. So if you come here, you see, for example, here is our Arduino Nano BLC Sense, the price, frequency. Here is the microcontroller. It's a 32-bit Nordic NERF52840. The core, how much memory it has, etc., etc., etc. Okay, so you can have you can see a lot of different microprocessors. You can enter this guide when you need. Okay, with more details. But another thing that you should, let's say, that I like to say when I talk about what microcontroller or what developing board I use in my projects, it's where you use, what's the application that you need for your microcontroller. For example, I will do something that I work with anomaly detection. Okay, so you need a very small model. The memory is not necessary to be big. I don't need a big processor. So, for example, I can use a Raspberry Pico. For example, it's a $4 PCB. I can connect an external accelerometer, and that's it. Because the model itself is only a few kilobytes. Okay, you should always remember that when we are talking about, for example, usually movement, or you are working with accelerometers or such, or temperature, or that kind of time series data. Usually, you make a kind of a conversion, a pre-processing. You take this kind of a serial data, okay, that's moving the time. I use a kind of a window. You take a piece of that signal and convert this for a group of numbers. So it will be the very complex and noisy time series data usually is converted to a tabular data. This tabular data is 30, 40, 100 features that is very easy to be used in a neural network model. So for such kind of, let's say, sensor classification, you can use very simple microprocessors. When you go to audio, for example, audio applications are a little bit more complex, because usually, despite of the fact that audio is also very noisy and complex time series signal, usually what we do is convert that a kind of an image of the sound, like spectrogram, for example, and that image will be classified using, for example, a little bit more complex neural models than we use here for such kind of data. Okay, we use, for example, convolutional neural networks. So it's a little bit bigger. So usually you have around 50, 60, 70 kilobytes of data. You also can use such kind of a device that is more powerful in terms of processor for very simple image classification, usually till 100 kilobytes. But if you're talking about a serious project where you need to do, for example, image classification, where models will be over 250 kilobytes, you need more serious, let's say, microprocessors or hardware, like the Arduino Pro series that I comment, for example, or Arduino Pro that you use with a Vision Shield, or, for example, you can use a Arduino Nicla Vision with a camera, for example. Okay, those are examples of devices that use what we call TinyML space, because we're talking about low power applications, because you need, are devices that usually run with small batteries, because I want them continuous working, always working. But besides the EdgeML, let's say umbrella, you can also find like a Raspberry Pi or smartphones or Jetson Nano that are hardware that used, when you see the CPU, the core is a Cortex A, for example, ARM Cortex A. It's much powerful, but also consume a lot of energy. For this side, we're talking about, I'd say, in terms of current microampere or a few milliamperes. Here I'm talking about amperes in terms of current, the current need to run such kind of devices. So the power needed in watts is bigger. The common among all those devices are that they are, let's say, offline. They don't need to be connected to the cloud. That's because it's EdgeML. We are in the edge of my network, okay? So I don't need to be connected. But when I'm talking about TinyML, that's more the focus of our workshop here. We're talking about such kind of a device. So several hardware, and we should, independent of what hardware is the best fit to my project, the hardware and the sensors, etc. We need to connect them to our Edge Impulse Studio. And so let's see what can be done when I look at all those guys. So the methods to connect that. Okay. In general, what do you do today here? We'll see several different ways to connect devices to the Edge Impulse Studio. That it's a tool that are in the cloud, correct? But how I capture data and connect them, and this data related with some kind of a microprocessor. The most simple way, and I think that everyone here did in the past, was the first, let's say, usually when you have the first contact with machine learning, with tiny machine learning, embedded machine learning, we use a cell phone to connect to Edge Impulse, and it's a fantastic, a valid way to do a lot of tests, a lot of analysis. And this is, we can do this connecting a cell phone, for example, through Wi-Fi to the Edge Impulse. Doing that, I can collect the data by the cell phone and online send the data to the Edge Impulse through a Wi-Fi communication. And we can download a training model from Edge Impulse to the cell phone and run inference in the cell phone completely offline. We'll comment very briefly on that. The second way we saw in previous lectures here in this workshop is taking, for example, officially supported microcontrollers, officially supported by Edge Impulse microcontrollers, like, for example, the Arduinos, the Nicla, the Portenta, the Nano 33, that you can connect it using a serial port, connect your terminal, capture the data, at the same time send the data to the Edge Impulse. You do this, let's say, in a synchronous way. You capture data and send, capture data and send there. And after you collect the data set here, you do all the training, the pre-processing, the training, the deploy of the model, etc. And having the deploy, you return the model. You can return your training the model to the device. But sometimes you have a device that you want to be connected, let's say, online with the Edge Impulse, but it's not, let's say, officially supported. For example, it's very common, you have, for example, ESP32 or sometimes new devices that you want to connect, even in spite of the fact that they are not officially supported. If I'm talking about lower frequency sensors here, so, for example, if I'm talking about accelerometer, for example, that is not a high frequency, I can take that data from those kind of several devices and use some tool that I recommend here to send the data using the serial. But the most important way to capture data and send to the Edge Impulse in the real world is doing this, let's say, offline. Because when you are doing a project, what usually you do, for example, suppose that you are collecting temperature from your temperature, wind velocity, wind direction from your city, for example. You connect data from maybe 1 year, 2 years, several days, because this variation is very low. Make no sense you have your devices or your sensors connected online through the serial port to the edge impulse. So what you do is you do some data collection in your environmental, when you do your experiment or your project. After you collect all the data sets, what do? You take this data, for example, as a CSV, is most common way to send tabular data, to handle tabular data. You take this and take all the data and send to Edge Impulse. You can have a few ways to do that. You can use including send like JSON, or you can do as a CSV connected directly. You have Edge Impulse has a good tool to help us to do that. Okay, so those are the things that we will do today. When you go through some of the projects here showing how to do that, of course, you don't have time to do a demonstration here or how it works. So I will show you how you do that. But it's important that every time, for example, if you go to the first one, for example, talking about the smartphone. Okay, we don't enter here because I think it's more, everyone here thought that, including we had some, I gave for you guys a lecture a couple of years ago and last year using cell phone to capture data from movement and send to Edge Impulse. But what I'm doing is I put here, for example, a complete, let's say, step-by-step guide you how to connect the cell phone, how you do capture data, how you training a model, etc. So I try to help you with, let's say, a side documentation that you can go. For example, let's click here in this documentation. When you click here, I go step by step, okay, with how you connect, how you capture data, etc., to do your project. Okay, so that's the idea, and we will go project by project. I don't enter in this project specific because it's more you guys know more than me how to handle this, no, using software. But I would like to call your attention this is not a toy. It's an important tool. You can, for example, have a data set with a lot of images. You can go to upload the image, work with that, and you can, for example, use your cell phone after, or to capture more data for your data set, or also to run. That's important. Not only capture your model, you will capture your data, but you can also do the inference. Suppose this is the real project that I did, for example, with my using here, for example, my money, if I have my money or not money. But important is you can download the model to your phone and work offline. Okay, it's a model that will work offline in your smartphone, and you can run the inference. Okay, so it's important, and it's very good for in this case specifically. For example, for audio, and for image, I use a lot the cell phone for testing models. For example, I will change models more quickly instead to have all the models sent to microprocessor. So I'm doing for the transfer learning, etc. So I do here, download to the cell phone, test the model, so it's quickly. I don't need to go to the physical world with a more complex device. I use the smartphone. Okay. The second one, now all of you know, have used it here. You saw here how I connect, for example, one of the most common officially supported device to the Edge Impulse, that is Arduino Nano BLE stands. It's very famous because one of the first book that talk about TinyML from Pete Ward and Dan and Pete. They wrote a book and they use all the examples of TinyML from TensorFlow-like micro. They use this kind of device, including nowadays if you go to the library, the TensorFlow-like micro library at the Arduino IDE, you have examples using this kind of microcontroller. Okay, so it's very common. You see this kind of device. Well, what you should do here with such kind of device, again, you can go here. I have a step-by-step, updated step-by-step with how you do that. You will call attention. I call you for one point here. But what you do here, you go to the Edge Impulse page. When you go to the Edge Impulse page, what Edge Impulse will do for you, he'll show you how you have here, including I have the link for the page at Edge Impulse. What do? You should download a program, a code that you run this code should run inside the microcontroller. And you select here, for example, if you are using Windows or Linux or Mac. And what you do is you download the code to your, upload the code to your device. And this code, what this code does, it connects to the serial. Through the serial, it be connected with Edge Impulse. Usually we use web serial. It's very easy to do that with the web serial. You do the connection, correct? And you can, for example, see all the sensors inside here. You can capture the data from the humidity sensor, the pressure sensor, the microphone, including if you have a camera connected to this Arduino using the Arduino TinyML kit developed by Harvard. You can also connect the image and send to Edge Impulse. Again, if you go here, you can have all the details how to connect and how to test. Okay, so it's very important. And the most easy way to do that is if you use your browser. Edge Impulse work in any browser in general, okay? But if you use Chrome is easy because with Chrome you can have a web connector. You see here in this workshop more in detail about how web serial works and some examples in the probably tomorrow, okay, with Jeremy. But that's it. Only I will call your attention, and when you enter in the documentation, Professor Jesus from Colombia called my attention last weekend with that Edge Impulse do upgrades every, let's say, every month or whatever, because they are, always introducing new features. One thing that's changing with Edge Impulse and the Arduino, because the shortage of the hardware that we got in the last years, Arduino launched a new version of Arduino Nano BLE Senses, the Heavy 2. And this, for example, has different sensors inside the PCB, inside the developing board. For example, there is not, instead of to have one sensor, one IMU with the 9 axes, so the accelerometer, gyroscope, and magnetometer. It has one sensor that runs the 6X and another one with the 3. It's a Bosch sensor. So they changed the sensor. You need to change the library. So it's a different way to connect. And what they are doing today, when you have a connection, for example, you always capture the 9X that are available. And you need to, when you run the impulse, you select for example, I only want the accelerometer. Okay, all the 9 axes will be connected. You select the three related to accelerometer when you define your impulse. Okay, but the capture will be in total. But it's a very simple. It's only the detail, and I explain in the documentations that in this documentation that you can find here in this link. that sent you to my GitHub as I comment. Okay, perfect. So this is also, you know how to do that. It's important to call your attention that one of the, for example, with those kind of devices that are officially supported, the first issue that I have is that it's only if I have hundreds or thousands of different microcontrollers in the market, Edge Impulse officially support, let's say, 20 different types of microcontrollers. When I say officially supported, because they have developed a program that you can, download or upload to your device to be connected direct to the Edge Impulse. But again, this is not a limitation. This is only something that is making your life easy for some kind of devices, more common devices. It's very good for us or for education when you are starting. But for real projects, like I said before, you connect all the data before in your data log and you send those data after to Edge Impulse. But for example, one of the other let's say, issue that I found with my students, and maybe you guys in your universities or in your project also find, sometimes it's not easy, let's say, to install the Edge Impulse CLI or CLI or the Arduino CLI that you need, for example, to do this kind of a connection here, you need the Arduino CLI. It's a let's say, it's a kind of IDE that will work in your terminal, in your command line, and you have a lot of steps that again is explained here in this documentation how you install that. Okay, but for example, for some device, including the view terminal, for C view terminal, this is one of the devices supported by our network. We sent a lot of devices for hundreds of those devices. Marco Zanaro coordinate this from ICTP and sent those devices to a lot of universities around the world, mainly in Asia. People in Asia, in Africa, they are using a lot those devices. Very good device, cheap device, and work very well. The good thing about this kind of device is when you go to the Edge Impulse page, include the documentation, say to you, first install Arduino CLI, but in fact, it's not necessary because what you should do here is to install a type of file. The name is .uf2. So this device, your computer, you see the terminal when you put in the boot mode as a external drive, like a pen drive. Okay. So what's happening is when you click twice here, put in the boot mode, what's happening is in your computer will appear like you have a drive. And when you have a drive here, what you should do is you take the file that you download for your computer and drag the file to the device, and that's it. And your device will be ready to be connected to Edge Impulse using web USB. So in this case, you go straight without to install the Arduino CLI. You can do that for other things, or Edge Impulse CLI for other things, like the next way to do that. But the easiest way to connect direct to Edge Impulse, for example, are using such kind of device that only you need is a .uf2 type of a firmware to install. Okay, so perfect. So now, so far, we saw how we connected officially supported devices to Edge Impulse. But I continue, suppose that, for example, I want to have suppose a ESP32 or other device that is not supported officially. I don't have a firmware to put inside this device to connect to Edge Impulse. I have a similar code to flash here that use the Edge Impulse used for a ESP32i. That is a special ESP32 with camera. But when you have the normal one without sensors or use external sensor, you can't use it. Suppose that You want to use a ESP32 with using the I squared C, for example, communication that I have here, to connect a accelerometer external. You can do that. So for that, you need enter with a program here, a program that you read your sensor, and what you should do use one application developed by Edge Impulse the name is Data Forward. That's worked very well for frequency, usually less than 4 kilobytes. Sample frequency lower than 4 kilobytes. For example, sound is not work very well because sound usually you need signals that goes to 8 kilobytes, 8 kilohertz of frequency, components of frequency, and to have 8 kilohertz of frequency, you need to do sample with the 16 kilohertz, the double, because it's the next frequency. So it's not work properly. Okay, so best is capture your sound outside and send those data as a wave data to the Edge Impulse by externally. Okay, but you can do that. Again, you can have a ESP32 motion classification project. I explain for you guys how step by step how you connect externally the sensor and do that. Okay, so it's important. This is another example that also you can find. It's a Hackster project that I did a couple of months ago when I used the seed Xiao sense. It's the same processor the Arduino Nano BLE sense, but there is no flash, no programming in Edge Impulse to put here. So what we need to do that, we need, for example, first you should have your program here. So you say, look, this is the library that I'm using. Is a LSM 6050, etc. I need to inform what's the library. It's a normal program. You come here and you capture the data. For example, I'm capturing the data from my accelerometers, and what I'm doing, I use serial print. When I do serial print, what I'm doing is send the data to the connection, to the serial connection here. So, right? I serial print. I'm sending the data to the serial channel. When I do that, I came here with the Edge Impulse data forwarder. I enter. I should have the Edge Impulse CLI installed, and using this kind of program, I can send the information straight to the Edge Impulse. So fantastic. But so far, I'm using, let's say, a kind of a synchronous connection with the Edge Impulse. I'm taking the data captured by the sensor and send straight to Edge Impulse. But it's important and most common, for example, you don't have it. Okay? Usually, as I said, in real projects, what we do, we capture data outside. So, for example, this kind of device, we also have here a microphone. Okay, I would like to capture a sound here, and I can use the data forwarder because, as I said before, with the microphone, I'm talking about 16 kilohertz of sample frequency here. So the data is so fast, I can use the serial connection. What I should do? I should take the data here, save locally, for example. So one way to do that is save locally. How I do that? For example, with a microcard. I can connect externally a microcard here, correct? Save the data, okay, as a dot wave, and doing that, I send to the Edge Impulse. So that's the way that we should do. I save the data here in my computer or in this in a spot in a tiny memory card, download to my computer, and from my computer I can upload this data to the Edge Impulse Studio using the data injection using one tool that permits this for me. One example a real example that I did this, you can find in this tutorial that I wrote. I capture a lot of voice data. Okay, I use this kind of support for the Xiao. You can $16 you buy this is very cheap. You have a display, and then you have also here a card header. So I capture my data offline, send the data to the cards, and the data here in the cards I send to Edge Impulse, and after that I did my training. So this is a way to do that. Okay, you can do this with several different type of device. You can do this with this kind of device, but you can do this, for example, with JPG data. It's also you can do that without problem. You can, for example, this is another project that I left for you guys in my GitHub, that you can find here a project where I download the CFAR10 image, and from that I send to the Edge Impulse, and I training a lot of convolutional models to compare what I did with the TensorFlow in using Jupyter Notebook. So I did this in my classes with my students. So you can do that. Okay, perfect. Another fantastic way to work. For example, we work in a project that was okay. It is interesting. Was okay to capture serial data for my computer. Okay, but in this case, I was interested in capture serial data. Okay, in the field. In fact, it was a project that we use in one of the projects with my students. They collected heartbeats from a robot here that we use for the simulations. It's a very accurate equipment to simulate disease, and they simulate atrial fibrillation. So we capture those data. We develop our code. We put our code in ESP32. Okay, and doing that, after I collected data. And when I had the data collected, what we did, we are collecting the data. We used, for example, with Windows, or in this case, with my student used it, he was working with Windows. He used a code that named PLX DAC, that you can take your CSV data and send this data to an Excel file. If you go here, you have all the project. You have here you have here the paper, and the paper there is the GitHub where you can find the code. Okay, only for you guys to know what we have here. We have from here we have the device here. We capture. Okay, this is the hertz we have here is the signal of the hertz. Went here in this sensor. This sensor went for a DAC here, just digital analog converter, because the output here is analog, but the point is the ESP32, there's not a good analog converter here, analog digital. So we use external one here. And this data was the data that we captured. And this data was captured in an Excel spreadsheet, okay? So the same idea, you have here the program that was inside to capture the data from the device. And it's very similar to the code that we use for a normal accelerometer. Use the PLX DAC here. Here you can enter here, there is a step-by-step program to do that. This works for Windows. Unfortunately, it doesn't work for Mac, for example, or Linux. So if you want to do that, you can use PySerial. PySerial is the same idea. You have your device here, and you can use a Python code here that you capture your serial data and send the data to your spreadsheet. So another way to do that. So you can have here, okay, all this information you can find there. Super. Also, it's very common. For example, my students have students doing just now a project. They are capturing data in a gym from a physical exercise. But the accelerometer, it's in the device, so I don't have in the previous case. There is no problem here. In this case, there is no problem to have a cable between, because let's say the patient was stable and I have a small cable, and I was capturing data from the heart. But what happens when I'm not close to my computer? I don't want to cables to my computer, so I can use Bluetooth, okay, to a cell phone, and this data in the cell phone sent to Edge Impulse. So what we did in this case, for example, what we did is, I have here a person doing the exercise, okay, in this wave here, okay, I have a small box. This is small box, I have here a shell, okay, the shell microcontroller, and the battery. This is the shell sense, where I have the accelerometer here. And the one thing very interesting about this device is they have a battery power controller inside. So you only need to connect the terminals of the battery. You should connect to the shell. So we are connecting here in small box, small roll here. So during the exercise, the data is sent by Bluetooth to a smartphone. They developed an application here, okay, using App Inventor, MIT App Inventor. So the data was captured from the exercise, was 2 boxes, 1 for each hand. So this data was captured and sent to the smartphone. So it's another way to send the data. So the data here in the device, again, you should have your code that capture the data from the accelerometer and send the data to the Bluetooth, send the data usando BLE. So in fact, he doesn't know, he sends a kind of a broadcast. No? The device here capture the data from here, and we can do 2 things. We can locally store inside the cell phone, the mobile phone, or you can send by Wi-Fi straight, for example, to Google Sheets. We do the 2 things. I wrote, you can find here, I wrote this tutorial where I explain how to do that. In fact, I think that when I did the tutorial, I only took the data, was only accelerometer, and sent to the spreadsheet. But for the project, what the students did, they did for 6 acts, not one for accelerometer. They developed by accelerometer and the gyroscope to have the complex type of movements, because they are classifying here what exercise, different types of exercise, and if the exercise is correct or not. This is very important. So it's a complex project. Okay. So they did local and send a backup to the spreadsheet, and worked very well. Okay. You also can do this by JSON, using JSON. JSON, it's a way you can encapsulate your data and send your data to Edge Impulse. Sean Himmel, you always say that the best way to do that is, he likes to use JSON because he said, look, with JSON you can use any type of data. You can take this data and send to the Edge Impulse, and that will not depend if the device it's supported officially or not supported officially. If you are doing online, if you're not doing online, or whatever. So you can capture your data, do put your data where you want, and after that you can encapsulate with JSON and send to Edge Impulse with all the information inside. Okay. For example, Sean has here, I put here, he developed a collab, a very, very nice collab. When he explained, for example, he was classifying image, but he would like, for example, to use, to took this image and send straight to the studio, okay, to classify those images, but using, because for comparison, he wants to use not convolutional, but DNN, direct neural network, full connected neural network. So he took all the data make all the pre-processing that he wants to change to grayscale, define the size of the image, and send those images using JSON straight to be trained in Edge Impulse. I use the same principle, for example, in this project, for wine classification, but in fact, was more than that, because this was the base of a project that a paper that we wrote when we have a lot of data, real data, tabular data, but was we need to send this data to the Edge Impulse to do a regression. So it's a little bit more complex, because you should send to do a regression, but also because how the Edge Impulse works, you should have a kind of the labels. And this is very interesting. It's very interesting to know how to do that, because there are situations. Suppose that you are doing something that you have several classes. With a TinyML, 3-4 classes is okay, but suppose you have 20 classes. In this case, I had 10 classes. That was the levels of the wine, for example. In this case, I didn't want to do classification. I want to do regression. So 0, 1, 2, 3, 4, 5 was the quality of the wine. Because I have, but using only a regression, I can have the output only one neural, correct? And we will have a number instead of different classes. So there is a trick to do that. Let's say it's called trick, but the way to do that, and I explained this in this. So when you have all your data, because you have your data, you have your labels, etc., you can use JSON to encapsulate everything and send. And this collab here, you open here, and they will explain step by step. So it's very interesting. So when you look all this, this complication here, it's not simple. But only to very quickly to remember what we saw. We saw that we can send data, capture straight from my cell phone, from my mobile, straight to the Edge Impulse, for example, using Wi-Fi. I can work with officially supported devices, where you can use, for example, Arduino CLI to download or upload a code here to your device, and using serial, you send the data here. You can also use a kind of a firmware wrote in a file with extension .uf2. Is a kind of a file that you can download you can, let's say, storage in your device, and your device will be read by Edge Impulse. In this case, you can read using web USB, that is the most simple way, or Edge Impulse CLI to read the data once you have your device connected. Okay. Or if you are using here a device not officially supported, it could be any device for low frequency samples, you can download your code to the device, correct? And you can use data forward, Edge Impulse CLI, command line interface, and data forward to send your data here. You can, the most common normal, you can use, create a data logger. You take your device, you storage your data in a local recipient, for example, okay? And you took this data and you can send to Edge Impulse later using data uploader, okay? Can be sound, can be image, can be tabular data as CSV, or can be JSON. It's more complex way to send any type of data to the Edge Impulse. I also comment with you guys, two cases when you capture CSV data, but one, when you have your device connect to your computer, so you have the example with the ECG that was fixed. I use cable. So what I did, I captured data, and I use the PLX DAK to take the serial data and send to a Excel spreadsheet, or you can use a Python program to take the data, let's say online, the data that are being generated here online, you do the storage of this data in this spreadsheet. And if you don't have, or if you don't want cable, or it's a way that it's very common, your device is not close to your computer, or you are movement parts, usually you can also do is work with a Bluetooth, for example. Of course, some devices you can have a Wi-Fi, and you can send straight by Wi-Fi. So one possibility. For example, if you are using ESP32, you can capture the data and using his internal Wi-Fi to send for your application, for your data logger. But for devices that only use Bluetooth, it's very common. A very small, tiny device only have Bluetooth because it's very low energy. Wi-Fi, you need a lot of more energy. Bluetooth, no, it's very low energy. And you can usually, you do a bridge. So you take the data, send, for example, to any device that can read a Bluetooth remotely. For example, the example that I show for you guys, we use a cell phone in application that we develop using MIT, the Invader MIT. That's great. And from that, you can store it in your phone, in your card, in your phone, when your phone has card, or send this data after that to Edge Impulse. Okay? That's it. I think that I tried to give you guys an overview about several different ways to, let's say, capture different type of the data with a different type of hardware. Again, was a lot of information in a very small amount of time. What I want to do here is only for you guys to know how to find the way. Again, I show you guys several tutorials that I have published about that. And don't forget that you have you also have here. Remember, I show you guys. You have here. It's in this. I left here. It's in my GitHub. I left here all my presentation and all several, let's say, detailed ways to do what I have briefly discussed with you guys here. Okay, super. So, thanks very much. I'm available here. I think that probably I have a few minutes. I left to Marco if you have some minutes to solve any doubts that you guys have. But again, I'm a co-chair of the TinyML 4D together with Marco, Brian, Vijay, and everything that you guys need will be available. You can discuss, help you with the project. The idea for us is to share all those stuff with universities all around the world. So thanks very much.